Hello, I'm Cannon Blake, and we're going to talk about vitamin C. Vitamin C, or ascorbic acid, is one of my favorite vitamins, if there ever was a competition. It's a nutrition that your body needs to form blood vessels, cartilage, muscles, collagen, and hormones. Overall, it's just really amazing. I didn't even list all the properties that it can do. Sadly, humans cannot make vitamin C, so we must attain it by eating fruits and vegetables. Yes, even vegetables like leafy greens and potatoes have vitamin C in them. Of course, some vegetables have more concentration than others. Broccoli has about 51 milligrams per serving, and oranges have about 70 milligrams per serving. But if you don't like broccoli, just take supplements like me. So let's talk about scurvy. If humans become vitamin deficient, humans develop scurvy, a disease that many sailors contracted at sea. These sailors went months without having vitamin C and led to anemia, exhaustion, spontaneous bleeding, and teeth loss. That's why when we see pilots, most of them have missing teeth. Also, there wasn't much dental hygiene at the time. Johnny Depp is an exception. And quick fact, they called it vitamin C as ascorbic acid and named it so because ascorbic means anti-scurvy. That's really cool. But let's talk about the molecular structure. Ascorbic acid is a acylic ester, a lactone, and is highly acidic with a pH of around 3. It is also soluble in water and is a white crystalline solid. It is soluble in water because it's polar at hydroxyl groups. So let's talk about the difference between ascorbic acid versus ascorbate. As we can see here, we just have a loss of the proton right here. The electrons are delocalized over the C2 to C3 bond, stabilizing molecule that causes the hydrogen of the C3 hydroxyl to become highly acidic and cause the whole molecule to be acidic. At about pH 7, the hydroxyl group at C3 is deprotonated to make ascorbate. Okay. Let's just back up a little bit. Let me talk about antioxidants. Antioxidants are compounds that inhibit oxidation. Oxidation is a chemical reaction which electrons are lost. Reduction is a chemical reaction where electrons are gained. Oxidation and reduction occur simultaneously. But if it's more easy to think, oxygen forms bond to a more electronegative atom, while reduction forms bonds to a less electronegative atom. A buildup of reactive oxygen species in cells, RS, which are generated during metabolism, can cause damage to DNA, RNA, and proteins, something that we know we all need. It may cause cell death. Antioxidants can decrease the oxidative damage directly by reacting with free radicals and inhibiting the activity expression of the free radical generating enzymes and enhancing the activity of or expression of intercellular antioxidant enzymes. As we can see in the picture, we have the production of RS and the DNA molecule. When it reacts with the free radical, it becomes oxidized and has damage. You know what DNA damage can lead to? Cancer, which we do not want. So it's a coincidence that vitamin C is a very amazing antioxidant. So ascorbic acid is a potent reducing and antioxidant reagent. As we see here, ascorbic acid molecule can directly donate electrons to reactive oxygen species, which is used to reduce metals like iron. Vitamin C also reduces non-iron from ferric to ferrous, which enhances intestinal iron absorption. It's just really all amazing. That's why if you wanted to increase your absorption of iron, they say to eat vitamin C with it. Okay. This is really cool. Vitamin C interact directly with reactive oxygen species. So see here. So we see right here, it donates the H. And that's because it deprotonates. Ooh. So this can also help with iron, like I said. Here I have a diagram of it helping. If you can see right here, the food iron goes through these process, and vitamin C helps reduce it from Fe3 to Fe2, which is very easier to, digest. So, how is vitamin C made? These probably look all very concerning, but we can do this. Okay. So let's break down this reaction. So we know D-glucose goes through a series of reactions until C1 gets oxidized, C1, and eventually the lactate ring between C4 and C1 occurs through a series of reactions. So it goes to reductase, glucose lactase, and L-gluconolactone oxidase, which is an enzyme. So we explore this a little bit more. So in many of these reactions, the water's H2O. Okay. So why can't humans synthesize vitamin C? So here I have a phylogenetic tree, and we see here that somewhere right here, we have lost the enzyme, like we said before. If you go back, we have lost the L-gluconolactone oxidase. Right here. So let me explain. In each step of a biosynthetic pathway, a substrate is converted to a product in reaction catalyzed by enzyme, right? Humans lack the gene coding for L-gluconolactone oxidase, the last enzyme involved in animal biosynthetic pathway of this vitamin, as we can see here. That does conversion of the L-gluconolactone into ascorbic acid. We probably lost the enzyme through evolution. Individuals carrying the mutation that doesn't produce vitamin C in the gene coding should have a less chance of surviving and reproducing. But inclusion of vitamin C in the human diet explains why our non-synthesizing ancestors did not become extinct, as they found this is effective compensation for the mutations in the gluconolactone oxidase gene. So some mammals can produce vitamin C on their own because they have the enzyme, like our favorite furry animal, dogs, and cats too. Because they have, even some yeast can produce vitamin C, as we see right here. It goes through a different reaction, but still can produce it. So let's wrap up. So we all know vitamin C is an important molecule. I use it every day. I take vitamin C supplements to improve my immune system. So something very crucial in 2020. I used to do vitamin C facial serum because ascorbic acid inhibits excess melanin production. Excess melanin production leads to hyperpigmentation. So I just really like vitamin C. Here are my references. Thank you very much. Goodbye.